Okay, this wasn't the sample test. This was the actual test, so I should have taken that off of there. All right, let's go over this. So first of all, let me explain once more because some of you are not clear on this. Now, there's all kinds of numbers like square root of 3, 5, -7 halves. Um, but sometimes you get numbers you can't do, like the square root of -7, because you can't find two numbers that multiply to make a negative. And so this will produce an I. And that's called an imaginary part. Complex numbers are numbers that are made up of real numbers, regular numbers, these kinds of things that you're used to, and imaginary parts. So they often are written as like square root of 3 minus 5 i's. Now, that's a complex number, but if there's no i's in it, it would be just the square root of 3, and it's still called a complex number, just doesn't have the imaginary part. So the square root of 3 is complex. And 5 minus 5i, 5 would be complex, and 7 over 2 plus no i's would be complex. And this would be 0 real plus a negative square root of 7. Square root of 7i has no real part, but it has imaginary part. That's complex. So pretty much every number you've talked about before is complex. So that's going to be complex, complex, and complex. They should have all been marked complex. Now, what's a real? Real is any number that doesn't have the imaginary part. So that's real, 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 and this is not real. So this doesn't have a square root of a negative or a fourth root of a negative, so it's real. This is real. And there's no negative in the square root, so it's real. Real is pretty much all the numbers you folks are used to. Complex is just a higher level, a bigger group, bigger name, and more inclusive name for numbers. Now, of all the real numbers, you can split them into two groups. The rational ones, which are ratio of two whole numbers, or the irrational, which are not. Now, that doesn't really help most students like you, so maybe a better way to talk about it is to look at the decimals. Now, if I look at the square root of 3, you'll notice there's no repetition pattern. This won't go on 0808 if I could show you more. It does not repeat. There doesn't seem to be a pattern. That makes it irrational. It's not a ratio of two integers. Now 5, they don't show you, but it repeats. It goes 0.000000. So I call that a repeating. Many math teachers just call it a terminating decimal. So, and let's look at -7 over 2. Oops, -7 divided by 2. It goes -17. Oop, I hit answer in there. Clear. -7 divided by 2. So that's -3.50000. Still rational. How about -7 divided by 3? That's -2.333333. It's repeating, so it's still rational. It's a ratio of two numbers. How about let's go 5 divided by 17. 29411 746 471. We don't see it repeating, but that's a ratio of two whole numbers. It will eventually repeat. I won't give you something that takes forever for it to repeat. This case, we have 7 times 7, 49 divided by 6. So let's see if it repeats or not. Since it's 49 divided by 6, it's a ratio of two whole numbers. It should repeat, and it does. 8.16666, and then they round it off, but it goes on 6666. So it is a ratio of two whole numbers. Itself is not a whole number, positive or negative, so it's not an integer. It's not irrational because it would have to not repeat. And it's not natural because that's just 1, 2, 3, 4, 5. Now, the cube root of 12. So the cube root of 12 is, so if you don't know how to find that on your calculator, you can always do the alternate. 12 to the 1 divided by 3 power. That's the cube root. And you will not find repetition in this. And so that makes it irrational. And if it's irrational, it can't be rational, integer, or natural. Now this one, I meant to put a 3 there, and the cube root of 125 is 5, and so we'd had negative 4 times 5, which is negative 20, which is an integer. It's not a natural, though, because it's negative. So then I would have colored that in and rational. But I didn't. And negative 4 times the square root of 125 turns out to be a non-repeating decimal, and so it's irrational. Now, the way I graded this is if you got it completely right, you got 2 points. If you missed 1 or 2, you got 1 point. If you missed 3 or more, you got 0 points. Okay. Hopefully that'll help you understand how to do those on a retest. Okay, it is very tempting to go 5 minus 3. 2 makes it simpler. But order of operations says parentheses, power. So we got to work inside the parentheses if we can do it. And in here we have subtraction and multiplication. And at that level, multiplication happens before subtraction. So we have to go, we got 5 minus 3. I'm going to leave that. I'm going to write it like I would like you to see you do it. This is going to be 12 minus 10 squared. Now, some of you tried distributing the square. When there's addition, you cannot. If it was multiplication, you could. So we got 5 minus 3. We still could do some stuff in the parentheses. 12 minus 10 is 2 squared. And now there's no need to keep the parentheses, but it helps us see that the square is acting on the 2 only, and we have to do powers before multiplication. So 2 squared is 4, so we have 5 minus 3 times 4. Still tempting to call that 2 out there, but we have to do the multiplication and powers and all that first. And we still have multiplication, so we have to do 5 minus 12, which is minus 7. Now let's look at this one. We have parentheses, so we have to work on that. It's tempting to add the 2 and the 3, but that's 3 is times this, so we can't. It's got to take it times whatever this is first and then add the 2. So 18 divided by 3 minus 1, we do division before we do subtraction. So we got 18 divided by 3, which is 6 minus 1 inside the parentheses, times the 3, and then add a 2. So 6 minus 1 is 5. That's times a 3 and plus a 2. We have to do the multiplication first. So we have 2 plus 15, which is 17. This one really befuddled. I like that word, befuddled. befuddled, folks. So let's just talk about it. So this is 25, or 5 times 5, times x to the 6th. That's a positive exponent, so I'm going to leave it up there. And y to the negative 2, which means it should have been divided by y twice. So I'm going to show it as divided by y twice. Now, when you move it down, the power changes sign. If you moved a positive up, it changes sign to negative. If it's a negative in the bottom, move it up, it becomes positive. Every time you move it across the division line, and you can only do it if it's all multiplication or division, you change the sign. So this says all of this. So let's just take a look at that. So that's 5 x to the 3rd, and we have a y to the minus 2. So I should probably move it down. And that's all to the minus 2. Well then, if that's to a minus 2, the 2 means I have 2 of these, but the minus says I should be dividing by the fraction. And when you divide by a fraction, you really need to turn it over and multiply. Or this is multiplied by this, except it says we're supposed to divide, so this should go in the denominator. And this is divided by this, but this says to divide, which cancels the divide out, makes it multiply. So this really should be 25 x to the 6th over y squared. 2 of these turned upside down. Y squared over 5x to the 3rd. Y squared over 5x to the 3rd. Now I could write it out. 5 times 5 times x, 6 x's, 2 y's, 2 y's, 2 y's multiplied here, a 5 and a 5, and 3 x's and 3 x's. But I think you can see that 3 of these x's will cancel 3 of them, and the other 3 will cancel the other 3, leaving just 1 for the x's. No x's, just the number 1. And we got a pair of y's that will cancel a pair of y's, so they're gone. And I got 25, and 5 times 5 is 25, or 25 is 5 times 5, and so that cancels both 5's. The only thing I have left is y squared. All that's gone, so it's over 1, and I don't need to show when it's 1 in the denominator. And it's times 1, because this becomes a 1, that becomes a 1, and that becomes a 1. So there's the answer. All right. Now, some of you tried to say, oh, a negative 2, I should put it down. No, the power's got to be negative, not the number negative. This says 3 negative 2's multiplied. This says x, 2 x's multiplied, but divide by them. So that should be x and x down here. This says 3 y's multiplied. This is a minus 4, so it stays down there, or it's minus 2 times 2 makes a negative 4. And we got x and x down there for the x to the 3rd. And we have a y. So this y would cancel one of the y's. None of the x's have anything to cancel, so I have y squared and x to the 5. And if I have to have positive exponents, I got to leave it down there. I can't bring it up and call it x to the minus 5. And these are not negative exponents, but a negative 2 will cancel a negative 2. And a negative 2 times negative 2 is positive 4. And 2 will go into that and make a 2. So I have 2 y squared over x to the 5. 4. This says 4.30 times 10 to the 3rd. Multiply by 3 tenths. Well, if I have 4.30 and multiply by 10 once, it turns into 43.0. Multiply by 10 and becomes 430. multiply by 10 again, and 4,300. Scientific notation. Since this is not in scientific notation, we go to the first non-zero decimal number, which is 3, then put the decimal, and then we have a 5 and a 2, nothing else. And now we got to multiply by or divide by the right number of tens to make it look like that. Well, if I multiply by 10, it gets bigger, and it's got to get smaller. So I got to divide by 10 once and make it 0.351, twice and make it 0.0351, which is what it is. So I have to divide by 10 twice. In this one, putting the decimal right after the first non-zero digit. There's no decimal, so I don't have to keep those. And times 10. Now, are we going to divide by 10 or multiply by 10? To make this, I'm going to have to multiply by 10. So I'm going to have a positive exponent, and I have to multiply by 10 once to move it to there, from here to behind the 7, and then twice, 3, 4, 5, 6, 7 times. All right. If I have 2 times 3 times 4, which I don't, you take 2 times 3, get an answer, and take that answer times the 4. Well, we have a number times a number times a number. So I'm going to do that. 29 times 9.2 times 10 squared. And it says that's 26680, but I want the answer in scientific notation. So we have to put the decimal after the first non-zero digit, so it's 2.668. And we don't need to keep that. If you're interested in that, there's only 2 digits of accuracy here, 2 digits, so I should really round this off to 2.7. But anyway, times, and now to make it look like this, that's bigger than this number. So I have to make this number times 10 to make it bigger. But how many times do I have to multiply by 10? Well, to get it to be the decimal here, I have to multiply by once, twice, 3, 4 times. Okay, so similar idea here. I have 1.32 times 10 to the negative 2, which actually means divide by 10 twice, and then divided by 7. And it tells me this number, 0.001887, and then it goes on. But in scientific notation, I've got to move the decimal past the first non-zero digit, so I got to write 1.8857. There's only 3 digits of accuracy, so I should probably round it off to 1.89. But I'm not going to worry about that right now. Now, this number is bigger than this number. And so to make it look like that number, I have to divide by some tens. And now I got to figure out how many. So if I divide it by once, it goes to there. That's 1. From here to here, 1, 2, 3 times. Okay, page 3, number 6. Now, some of you misread this and you thought this said 5x to the third, but that third's inside the root thing. So this is 5 times x, and the cube root, I'll move it over here so it's clearer, of 48. Now I got to break it down. I know 6 times 8 is 48, and 6 is 2 times 3. 6 times 8. 8 is 2 times 4, which is 2 times 2. So that's 48. You can check it, multiply it out. And then we got x 6 times. And we're taking out groups of 3. Well, there's 3 2's. That will come out as a 2 to multiply. There's 3 x's. That'll come out as an x. And 3 more x's come out as another x. So I get x squared. So I've taken those out, those out, those out. So the only thing left in there is 2 times 3, or 6. So I have the cube root of 6, not any groups of 3 there. And I got 5 times 2, and x times x squared. Now these are both square roots, so I'm looking for pairs. 35 is 5 times 7. And I'm looking for pairs in here to bring it out. 32 is 2 times 16, which is 2 times 2, 2, 4, 8, 16, 32. And 9 x's. Writing it out so you can see it. If you know how to do this, you don't have to write it all out. 14 is 2 times 7, and for some reason people ignored that x. And we have 8, which is 2 times 2 times 2, and an x. Now you can take a pair of 2's out as a 2, and a pair of 2's out as a 2, but they're going to cancel. So a pair of 2's will cancel a pair of 2's underneath. Now there's not another pair here, but a single 2 would cancel a single 2 underneath. So that only leaves a pair of 2's to come out, as far as the number is concerned. And this x would cancel a single x. So we have a pair of x's, another pair, another pair, another pair. We have 4 pairs come out as 4 singles, so that's x times x times x 4 times. And now we have, let's see, we took a pair of 2's and a pair of 2's, and a second pair of 2's. We cancel that pair of 2's, so there's, oh, and that was the 2 from the 14. So now that 2 will cancel with that 7 will cancel with that, and x will cancel one of the 4 x's, so that's x to the 3rd and a 5. And I think we brought those out. We canceled that, canceled those, canceled an x. We brought those out, so pretty much everything's out, so that's the answer. Okay, so we have 3 square root of 20. 20 is 4 times 5 times x. Square root, we're looking for pairs, so that 2 could come out. And this is all multiplied, so it's times 2, leaving in a 5x. There's not any doubles of anything in that, so we got 2 square root of 5x. Now, whatever the square root of 5x is, this is the same thing, and we have 6 of them plus 2 more of them makes 6 plus 2, 8 of the square root 5x's. 1/5 power means 5th root. 64. Well, that's 2 times 32, which is 2 times 16, which is 2 times 2 times 2 times 2. 4 times 4 is 16, times 4 is 64. 8 x's and 3 y's. And we're taking our groups of 5. 5 2's. Come out as a 2. 1 stays in. 5 x's out of the 8 come out as an x. That leaves 3 of them still inside. And 3 y's, not enough to take anything out, so they stay inside. Okay. If you put x's in here, if you put in 0, none of these have very much significance. But as you get further and further, go out further, like x is 2, 1 or 2 or 3 or 4, if we multiply 4 5 times, that's a whole lot different than 4 multiplied 4 times or 4 multiplied 2 times. This becomes the most powerful term the further you go from 0. And that's why we want you to know about the degree of this. This looks like a degree 5 equation. And you're going to learn more about that as you get more into this. So the degree is 5, and how many of this x to the 5th we have is called the leading coefficient. We have 2 of them. Now, if the one with the highest power is the most powerful near 0, that's most power far from 0, close to 0 is the least power. So that's the 5x squared. Same here. The degree, highest power is 3. How many of the x to the thirds do we have? -4. Which one's most powerful close to 0? The one with the lowest power. 1 x to the 0, the constant. Most powerful far from 0, that's the one with the highest power. And that's those. Okay, 8. So an 8, this is all addition. There's only, you might think of this as -1 times all this, but you subtract all of this, which means we're supposed to add a negative of this, add the opposite of this, add the opposite of this, and add the opposite of this plus, which is the negative of that. Once we do that, so that there's nothing here to distribute, we can drop that, and we're just going to combine like powers. So, see, my highest power here looks like it's x to the third, and I have -3 of them, and -3 more of them makes -6 of that highest power. When you're adding or subtracting terms, you do not do anything with the powers. You keep the like ones together. You don't multiply them, add them, divide them, anything. Then we go to the next highest power. It looks like we got some x squareds and 5x squareds and 7. That's 12 of those x squareds. Next high power is x to the first. We got 15 of them and -8 of them. So that's 7 of the x's to the 1. And then the one with no x's, that would be the 5. Over here, we're adding, so we have nothing to distribute. Here, we're multiplying, so we got to multiply this times this and that. So 3x added 5 times, 3x plus 3x plus 3x plus 3x, is going to be 15x when I do 3x is added. And 3x times -2x, 3 times -2 is -6, and x times x is x squared. Nothing to distribute, so I can drop the parentheses and go plus x, like 1x, plus 7x squared minus x to the third. Now I'm going to, excuse me, kind of tickle my nose. There we go. Highest power is x to the third. We got minus 1 of those. X to the seconds, we got minus 6 plus 7, so that's plus 1x squared. So I could put a 1, but I don't need to. And x's, I have 1. So 15, no, excuse me. 15x's plus 1x is 16x's. 7x squared. It's not ringing a bell for the answer. So 15x minus 6x squared. So I got minus 6x squared plus 7x squared, which is 1. Oh, I got minus x to the third plus 1x squared plus 16x. Did I have that on my key? Doesn't sound familiar. I hope I didn't make a mistake on correcting these. Yep, I had that. Okay. Okay. Next one. We don't know how big it is, the two, but whenever you multiply a couple of quantities, you're finding the area. So I want to make a length and a width, and I don't care which way you go for those, but I got to make a length, and I'm going to call x, so I'm going to just call that length x, and I'm supposed to have two x's, so I'm going to do another one that's the same length as that, trying to make them look about the same length, plus 1. I'm just going to make 1 be that size. So this is 2 x's plus a 1. And I'm going to go down to make my rectangle. I'm going to do an x, and it should be about the same length of x, so that's about to there, so that that looks like a square, x by x. And then plus 3. If that's a 1, then 1, 2, 3. And then we finish our rectangle, and we draw dotted lines or whatever where the x's and the numbers meet, and this is 3. So the area of this rectangle, this square, is x times x, or x squared. This one is x by x, which is x squared. This one, this area right here, is 3 times x, which is 3x. And this is 3 times x, or 3x. And this is 1 times x, which is just x. And 1 times 3 is 3. Now, what do I have? Well, I have 2x squareds. I have 6 x's this way, and I got 1x that way, and a 3. And that should be what I get when I multiply this. 2x times x, 2x squared. 2x times 3, 6x. 1 times x, 1x. And 1 times 3, 3. And now I said simplify when we get done here, so those are like terms, so we get 2x squared plus 7x's plus 3. There's the model, and there's showing the products in this. Okay, we got 3 quantities to multiply. Now you take this times the first one and take that answer times this one. Not this times this and this times this, and then multiply them. This times one of them. You can take this times this one and take that answer times this. I'm going to do this times this, which is 6x squared plus 15x, and I'm going to multiply it by x minus 1. Now, some of you don't like the way I do it in class, so I'm going to do it the distributive property way. First, 6x squared times x is 6x to the third. 6x squared times minus 1 is minus 6x squared. 15x times x is 15x squared. And 15x times the minus 1 is minus 15x. These are like terms. They're both x squareds. These are not. So I get 6x to the third. Minus 6 of them plus 15 is plus 9x squared minus 15x. Now I could have done it my way, which is 6x squared plus 15x times x minus 1. X times that, 6x to the third. X times that is plus 15x squared. Minus 1 times 6x squared is 6x squared. Minus 6x squared. And minus 1 times minus 15x is minus 15x. And 6x to the thirds. Those make 9x squared minus 15x. Okay, this one. So if I got x squared plus x plus 3 times 5x squared minus 2, I got to take the 5x squared times each one of these, the 5x squared times that, 5x to the fourth, 5x squared times that is plus 5x to the third, 5x squared times 3 is 15x squared. Minus 2 times that is minus 2x squared, so I'm putting it under the one that matches, like terms. And minus 2 times x is minus 2x, and minus 2 times 3 is minus 6, adding up the like terms. Now, if you just did this times these, and then this times these, you'd have this, and then these just following it. Anyway, we get 5x to the fourth plus 5x to the third plus 15 minus 2 is 13x squared minus 2x minus 6. And finally, the back page. Now, some of you forgot the 2 steps of factoring and did all kinds of crazy things. First step is to factor, if there's addition, factor out common monomials or common numbers. What goes into 3x and into 15? Well, 3x minus 3 times 5, there's a 3 in both of them. So this becomes 3 times x minus 5. 3 times x, 3x. 3 times negative 5, negative 15. And 15x, there's no addition here. It's just 3 times 5 times x. Now, what can I cancel? Well, the x and the 5 are tied together with a plus or a minus. Therefore, the only thing that'll cancel it is something that looks identical. I can't cancel the 5 separately or the x separately. I'd have to have an x minus 5 up here for it to cancel. So this is not going to cancel. So I can't cancel this x with that. I can't cancel the 5 with that, but I can cancel the 3's. And so the only thing I can do is call this 5x over x minus 5. All right, this one really caused people problems because they didn't do what I just said, pull out what's in common. So we have 8x squared minus 18 divided by 4x to the third plus 12x squared plus 9x. So we have 2 times 2 times 2 times x times x. I'm writing it out just because some of you don't see it. Minus 2 times 9, which is 3 times 3. 9 times 2 is 18. Over 2 times 2 times x, 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 plus 2 times 6, which is 2 times 3 times x, plus 3 times 3 times x. Is there something I can undistribute here? Well, there's a 2 in this, and there's a 2 in here. There's no more 2, so I can't take those out. I hope I'm at the right place here. My disk got full, and so I had it shut down. All right, so I factored this, factored the 18, factored this and this and this for each of these, and I see a 2 in both of these, nothing else that's in both of them, so I'm going to pull the 2 out and call this 4x squared and minus 9. And let's see, 2 2's, no 2's, can't take a 2 out. 3 x's, 2 x's, and there's an x in each one of these, so I can take an x out. And that would leave me 4x squared. That would be 12x. And this would be plus 9. Now, if you do that, you should be able, if I've made the problem correct and haven't messed up, be able to factor some of here. So we got 2 and x squared minus 9. So I'm going to dig out a couple of strips of paper here that we've been using for those of you who are doing this. The middle term is 0, so I'm going to line 0 with 0, and I'm looking for 4 times negative 9, negative 36. Oh, 6 and negative 6. So this is going to factor to some x's plus 6 and some x's minus 6 if I move numbers around. And I need to have 9, so this should probably be 3 and 3. I'll take a 2 out of this and leave a 3, and that would make 2x. And I'm trying to get 4x squared, so I probably need a 2x here, and that has to come from this one. That leaves a 3. And now I get 4x squared plus 6x minus 6x plus 3 times minus 3 is minus 9. So the middle terms cancel, and I get the 4x squared minus 9. Now the denominator, I have an x out already. I have 12 in the middle, so 0 with 12. And I want to get 4 times 9, 36. Let's see. 3 times 9 is 27. 8 times 4, 32. Oh, there it is, 6 and 6. Oops, 6 and 6, you can't see. 0 there. So it's 6 and 6. So I'm going to go some x's plus 6, some x's plus 6, but I have to get 9. So again, we're probably moving 2. A 2 out of there goes here, leaving a 3. And a 2 out of there leaves a 3 and puts a 2 there. So I have a 2x plus 3 and a 2x plus 3. 2x minus 3 and a 2x plus 3 won't cancel. This doesn't reduce. So my answer is going to be 2 times 2x minus 3 over x times 2x plus 3. And if you wanted, you could take the 2 times that and call 4x minus 6. And x times this, 2x squared plus 3x. Not necessary. That's an answer, but that's fine. Oh, darn. Missed twice. Got out of the pattern. Okay, hopefully you saw it. These cancel. These don't. So we get this and this. It was x plus 6, x plus 6, but I moved a 2 over here and a 2 out of there. Anyway, that's how it factors. 2x plus 3 and 2x plus 3 is that. Okay, some of you folks did some strange things on this. This is just subtract, so you don't take 5x times both of those, it's subtract. And a subtract just means you need to subtract both of those. So we're going to have 5x minus 4x minus 2 over the x squared minus x minus 6. And combining like terms, we just get x minus 2 over x squared minus x minus 6. And this is not squared, so we're not going to factor it. But this one has a square. We're going to try to factor that. So I'm going to put minus 1 with 0. There we go. The minus 1s are with 0. And I got to get 1 times negative 6. And that happens right there. So this factors to x plus 2 and x minus 3. Let me tell you a little secret. I was hoping that this would be x minus 2 and cancel that one, but it doesn't. So this doesn't cancel either one of these. So my final answer can be just that, or x minus 2 over x plus 2 and x minus 3. Either one of those. The only thing that was able to simplify on this was to combine the like terms there. Okay.